Hello students, this will be a short video on how to do converse of the Pythagorean theorem. So right here it says our essential question is how do I use the Pythagorean theorem to determine if a triangle is right or not. So keep in mind Pythagorean theorem only goes or only works with right triangles, and that's the whole point of the formula that Pythagoras said, hey man, if you give me two sides of a right triangle, I can figure out whether it is right or not. Okay, so his formula was a squared plus b squared equals c squared. So if you give him sides a and b, he can figure out c. Or if you gave him c and b, he could figure out a. Kind of that idea. So the Pythagorean theorem converse. Today we're going to be focusing on this term converse, which is the idea of determining if a right triangle is present utilizing or using the Pythagorean theorem. So again, do we have a right triangle given these three numbers using the Pythagorean theorem? So if blank is true, then the triangle is a right triangle. So right here we're going to put if. So if a squared plus b squared equals c squared is true, so I'm going to write that here. If a squared plus b squared equals c squared is true, then the triangle is a right triangle. So to determine this, you have to substitute the values for a, b, and c into the formula. Substitute those values. So whatever value for a, whatever value for b, whatever value for c, you have to substitute them into the formula, which is what you've been doing. You've been doing that for, a week or two now. You're good. It says use the smaller two values for a and b and the larger value for c. Now keep in mind that c is always the largest side, 100% of the time. It is the largest side, so that makes sense that the largest value, or I shouldn't say the largest, it's the longest side. It's always opposite the right angle, and it's called the hypotenuse. So that makes sense that we would use the largest value for c. And from there, it's really just simple as that. If the statement is true, then it is a right triangle. If it's true that a squared plus b squared equals c squared, then it's a right triangle. If the statement is false, then it is not a right triangle. So let's look at our first problem here. It says determine if the triangles below are right triangles. We're given the numbers 7, 25, and 24. Remember, we always identify where is our c side. This is our c side because it's the largest value, or the longest side. It's opposite the right angle. It's called the hypotenuse. Great. So if our formula is a squared plus b squared is equal to c squared, and in this formula, we substitute, like it says, the values up here. Remember, we substitute the values for a, b, and c. So if a, and I'm going to call this side a and this side b, if a is 7, we have 7 squared plus, I ain't even going to lie to you, big dog, that's kind of small, huh? That is really small. And I'm on an iPad. It's crazy. So if A is 7 and B is 20, if B is 24, looks like that's 24, so we're going to go with 24. If B is 24 squared and C squared, or C is 25, then when we plug that in, we have 25 squared. If this is how we set this up, if this is a true statement, then yes, this is a right triangle. If not, then no, it is not. So now, let's do our math. 7 times 7 is 49. 24 times 24 is 576. When you add 576 to 49, or 49 plus 576, you're going to get 625, which is perfect because 25 squared is 625. So again, 625 is equal to 625. So yes, this is a right triangle. And that is how you do the converse, okay? So looking through the rest of the assignment, you're going to do 2, 3, 4, 5, 6, all the same way. But I do want to talk about a few of these. So down here, 2 and 3 are the same, so you're good there. 4, you're good. I want to highlight that on number 5, it says could not. So that means 3 of those will work. One of them won't. And keep in mind which side is C. Hint, 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 wink, wink. We just did A. This one here. I'm not saying that's the answer, but I'm saying that we just did this one right there. So work smarter, not harder. But for the folks who don't watch the video, they won't see that. I'm going to undo that. But know that, again, A we just did on number 1. Or part A for number 5 we did on the first problem. On number 6, it says, which of the following triangles are right triangle? Same idea. You would just circle whether it's A, B, or C. But notice it says which of the following. So it could be more than one. So if it's A, B, and C, then you circle A, B, and C. I am not saying that's the answer, and that's not a hint. I can't wait to grade this and see all the yahoos who put A, B, and C. Lastly, the last 2 problems, or 3 problems. It says Mike has 3 slabs of wood. There are 30 inches, 40 inches, 50 inches. Hint, hint, hint. You're going to need to do something like draw a picture. Okay? So, like, maybe you can use this one here. But if I were you, I'd make a bigger picture. That's my hint there. And on number 8, it says 3 squares in the areas are shown below. Could they be positioned to form a right triangle? Why or why not? I want to give you a hint. If you made it this far in the video, 7 minutes in, because I said this was going to be short, but yeah, I'm just trying to be a liar. I apologize. If you made it this far in the video, I want you to notice something. These are pictures of squares. And it says, like, for example, 12 inches squared. So you don't actually need to square anything. Because normally we do A squared plus B squared equals C squared. This is already A squared. This is already B squared. And this is already C squared. So really, you could just add up 12 and 22 and tell me if they equal 39. And you'd be done. But hey, don't tell anybody this. If you made it this far in the video, you deserve to know that. And then the last part. It says, how do you determine if a triangle is a right triangle or not? That's a free response answer. Y'all have a blessed day. You're loved, valued, cherished, respected, and appreciated, all right? I'll see y'all when I get back. Take care.